All right, hello to period 4B and period 5. Period 4B, you are watching this on Tuesday, October 31st. Hopefully you just did awesome on your parallelogram quiz. Period 5, you're going to start the video on Monday, October 30th, and then you're finishing it on Tuesday, October 31st. So just a fresh reminder that we are in our quadrilaterals unit. We have, let's see if we want that on. We do. We know that a quadrilateral has 4 sides and its angles add to 360. We've spent a lot of time talking about the parallelogram and the 5 properties of that. And so our objective over this lesson is to talk about the properties of a rectangle, the properties of a rhombus, and the properties of a square. So please keep in mind that a rectangle is a parallelogram, a rhombus is a parallelogram, and a square is a parallelogram. So those 3 quadrilaterals contain all the properties of a parallelogram plus some special ones that make them unique. So if you can turn to page 8, throughout this lesson you're going to find several times where you're going to want to pause and really view the document, take the notes. So right now I already have some things filled in, so you might want to pause here and jot those down. I've also uploaded a completed version of this page 8 and page 9 onto the modules, so you can access that as well. So when you're ready, the 5 properties that I have filled in here are the properties for a parallelogram. And because a rectangle is a parallelogram, a rectangle has these 5 properties. Opposite sides are parallel and congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Okay, the markings would look like this. Opposite sides are parallel. Use the triangles for that. Opposite sides are congruent. And the ones that are special for a rectangle are that there are 4 right angles. So yes, my opposite angles are congruent, but more specifically, the angles are right angles. And if you need colored pencils, you know where to find them. Okay? So all the angles in a rectangle are 90 degrees. Okay? And the diagonals of a rectangle, not only do they bisect each other, but the diagonals are congruent. So segment AC is congruent to segment BD. And that's a little bit hard to mark here, okay? But just note that those diagonals are the same length. And because they're bisected, that means that segment AE is congruent to segment EC, which is the same as segment DE and the same as segment EB. That's something that's really different from the parallelogram, because in a parallelogram, the diagonals are not the same length. So let's look at some examples here. Okay? In example 1, we have a rectangle. We want to make sure we always read carefully at what quadrilateral we're looking at. Then we'll know the properties that are applied to that quadrilateral. So we know that AB is 15, AD is 8, and AE is 8.5. So if we're asked to find the perimeter of the rectangle, we need all 4 sides. Well, the opposite sides are congruent. And so the perimeter there is 46 units. We're adding 15 plus 8 plus 15 plus 8. Okay, EC is the other part of this diagonal, and the diagonals are bisected. So EC is also 8.5. Remember, a rectangle is a parallelogram, so all of those properties hold true for the rectangle. Now for AC, that's the entire diagonal. We just want to add these 2 lengths together. The small plus the small is equal to the large. So AC is 17 units long. And because the diagonals are congruent, if AC is 17, BD, the other diagonal, is also 17. The last 2 questions are asking about angle measures. The measure of angle ADC, that's 90 degrees. All the angles are right angles in a rectangle. And the measure of angle BCD is also 90 degrees. Okay. Second example here at the bottom, I've already labeled the given information. This too is a rectangle. And we have a couple measurements here. So one thing that I want you to note is this 50 degrees is referring to just angle ZXY, not the whole angle WXY. All right. Now, I'm asked first to find the measure of angle WXZ, which is this other part here. Well, all the angles in a rectangle are 90 degrees. So all of angle X is 90 degrees. Well, if the blue part is 50, how much would I have left? We're using the angle addition postulate here. That would be 40 degrees, because 40 degrees plus 50 degrees would give me 90 degrees. I'm asked for PY, which is just part of the diagonal. So remember that our diagonals are congruent and they are bisected. So point P is a midpoint. That means that ZP is 6, PX is 6, and WP would be 6, and PY would be 6. That way all 4 of those segments are the same length. The next one I'm looking for is the measure of angle WPX. That one's right here. Okay. A little bit more challenging on this one, but we can do it, okay? If you look at, I'm kind of asking you to remember some things from your middle school geometry. If you look at this triangle WPX, all right, it's an isosceles triangle. 2 of the side lengths are the same, 6 and 6. That means that these angles here are the same, 40 degrees and 40 degrees. And then recall that all the angles in a triangle add to 180. So 180 minus 40 would give us this angle WPX. That would be 100 degrees. Okay, the last thing I need is WX, and we don't know how to do that one yet. So there you go. Happy birthday. Skip that one. Okay. Head on to the back here. You want to go ahead now and press pause and work on these 4 problems. Make sure you set up the equation using your properties and then solve for not only the variable x, but also the side length that you're looking for, or the angle measure that you're looking for. So press pause and do that now. Don't just wait for the answers, really press pause. Okay, hopefully you're coming back and you have completed those 4 problems. Here is a quick key for you to check. I would encourage you to, again, press pause, really take a look at your work, take a look at the equations, and ask a friend if you have any questions. Once you have that, we're going to go ahead. We have 2 other examples here, okay? This is awesome geometry, all right? I've already gone ahead and graphed each quadrilateral according to the directions. If you need to pause, which you probably do, plot those 4 points, grab a ruler and connect them, and make your quadrilateral. And we want to determine if this is a rectangle, okay? And we're going to use the slope formula on the first one and the distance formula on the second one, all right? So if we think about the slope formula is y2 minus y1 over x2 minus x1, right? And if I find the slope of all 4 sides, that could help me to determine if this is a rectangle, because I can look for 2 things. First of all, I need my opposite sides to be parallel. That would mean that they have the same slope. Okay, that would show me that I do have a parallelogram. And now specifically to get a rectangle, I need to have 4 right angles. So I need to make sure that my adjacent sides are perpendicular. That's going to give me those 4 right angles. Okay, so in order to have lines that are perpendicular, my slopes need to be the opposite reciprocals. All right, so I'm going to find the slope of side QR, the slope of side RS, the slope of side PS, and the slope of side QR. Now we're on a graph, so you can do rise over run. I'm okay with that. If you want to use the slope formula, you're welcome to do that too. Okay. So again, if we're doing rise over run here for QR, I'm rising 2, and I'm running 1, 2, 3, 4, 5, 6. So 2 over 6 simplifies to be 1/3. Press pause and find the slopes of the other 3 sides. Okay, and you should find that indeed the opposite sides are parallel because they have the same slope. Okay, so if I put my markings here, opposite sides are parallel. Okay, and my adjacent sides, well, they're not opposite reciprocals. The opposite reciprocal of 1/3 is not -4. So although I do have a parallelogram, I do not have a rectangle because I don't have 4 right angles. Okay, so this is not a rectangle. I'm going to write it out here. QRSP is not a rectangle because there are not 4 right angles. And I verified that not with my eyes, but using the mathematics, okay, using the numbers shown there. Okay, so let's try one more here. Again, I've already plotted the points. If you need to pause and go ahead and do that, please do so. Okay, this time we're going to check distance formula. Right, we're using only the distance formula to verify that this is a rectangle, and maybe it's not. Okay, it looks like it is. I would have said that. The previous one looked like it too, but it wasn't. We checked with the numbers. So this time we're doing distance formula. So the first thing we need to check is that opposite sides are congruent. That would give me a parallelogram. And the next thing I'm going to check is whether or not my diagonals are congruent, because that's a property that is specific to the rectangle. Okay? And so if the opposite sides are congruent, that would give me a parallelogram. And if the diagonals are congruent, that would confirm that I have a rectangle. So if you do your distance formula, just a reminder, a friendly reminder here, a square root of x2 minus x1 squared plus y2 minus y1 squared is your distance formula. So you're going to do that for not only all four sides, but also for the diagonals. Okay, press pause and do that now. So you're looking for the length of JK, the length of KL, the length of ML, the length of, JM, and then the length of JL, which is a diagonal, and MK, which is a diagonal. And if you wanted to do Pythagorean theorem, that would suffice here as well. So press pause, do those calculations. We do find that opposite sides are congruent. This is what the markings would look like here. The opposite sides are congruent. And then my diagonals, okay, for those lengths, I get the square root of 65 for each diagonal. And that can't be simplified. So since my diagonals are congruent, this is a rectangle. Okay, JKLM is a rectangle. And that's because my diagonals are congruent and my opposite sides were congruent, and that put it into the parallelogram family to begin with. All right, so again, hopefully you've completed both of those. Make sure you're not just copying the work down. Period 5, this is where technically Monday would end, but if you're ready to go ahead, that's totally fine. Otherwise, you're going to finish this up tomorrow on Tuesday. Period 4B, we're still going strong here. All right, so now we're going to take a look at our rhombus and then in turn the square. So if we're checking out the family tree, we can see, yes, that rectangle was a parallelogram. The rhombus is also a parallelogram, so it's going to get all those properties. And then the square is a combination of a rectangle and a rhombus. So on page 9 here, we'll outline the properties of a rhombus and a square. I already have the ones completed that come from the parallelogram, okay? And then we just have to talk about the ones unique to a rhombus. So, special about a rhombus, all sides are congruent. Okay, we talked about that on our family tree. All right, so segment AB is congruent to segment BC, which is congruent to segment AD, which is congruent to segment DC. All four of those sides are congruent. 1, 2, 3, 4. Okay. Yes, the opposite sides are parallel. And yes, the opposite sides are congruent, but what's more special is that all sides are congruent for the rhombus. So the diagonals bisect each other. Okay, so AE is congruent to EC and DE is congruent to EB. The diagonals are not congruent for a rhombus, but the diagonals are perpendicular to each other. Okay, so where they intersect at point E, those are all right angles. So I'm going to put a box here, a box here, a box here, and a box here to show those are all right angles. Okay. The other special property for a rhombus is that the diagonals bisect the opposite angles. Here's what that looks like. All right. Angle B has been bisected into two congruent parts. Angle D has been bisected into two congruent parts. And since my opposite angles are congruent, those four individual angles are congruent. And we can do a couple extra markings here. The same happens with angle A is bisected and angle C is bisected. Okay. So the measure of angle BAE is congruent to angle EAD and BCE and ECD. Okay? and then we have the last blank there. So when we turn to look at a square, okay, sorry, going strong here. When we turn to look at a square is a parallelogram and a rectangle and a rhombus. Okay, so we have lots of things that we know about the square here. All right, and I'm going to go ahead and put up the notes for square. Okay, so press pause, fill those out. All right. In summary here, all sides are congruent, all angles are right angles. The diagonals are congruent. The diagonals bisect each other, so all 4 of these segments are congruent. Okay. And the diagonals are perpendicular to each other. All right. The only other thing I would add here is because my diagonals bisect the angles, these are all 45 degrees, no matter what. So square is easy because they're all similar in measurements. All right. A couple examples for us. Okay, so example 1 here. Read carefully. This is a square. Right, so all sides are congruent, all angles are 90 degrees, and we're going to use those things. So if AB is 7.1, that means that all sides are 7.1. And so my perimeter, 7.1 times 4, would give me 28.4 units. Right. Now AE is 5, and that means that all of these segments of the diagonals are 5. So EC is 5, then AC, the whole thing is 10. BD, that whole thing is 10. Okay. My angles here, angle ADC, that's a right angle, it's 90 degrees. Now if I'm looking for angle BEC, my diagonals are perpendicular, that's 90 degrees, okay, because a square is a rhombus, that's a property of a rhombus. And angle ABE, that's just this one here. Well, remember that whole thing is a right angle, and the diagonal bisects the angle, so that would be 45 degrees. And now we have in example 2, we have a rhombus. All right. So I know that AB is 10, BD is 12. That's the diagonal. The diagonals are not congruent in a rhombus. AE is 8, and then angle ABC here is 110 degrees. All right. So if I want the perimeter in a rhombus, all the sides are congruent. So if one of them is 10, they're all 10, and that perimeter is 40 units. EC, my diagonals are bisected, so if the top part is 8, the bottom part is 8, and that means that whole diagonal there is 16. Now again, my diagonals are not congruent in a rhombus, the other one is 12, okay? But that diagonal has been bisected, okay, because that's a property that a rhombus has from a parallelogram. So segment BE is 6, because the whole thing is 12, divide that in half, this would be 6. The measured angle ADC, opposite angles are congruent. That's a property from a parallelogram. So measured angle ADC is 110. Measured angle BEC is here. Well, my diagonals are perpendicular. All right, so that's 90 degrees. And the measured angle ABE, just this one here, I'll highlight it in yellow. Okay. My angles have been bisected by the diagonal. So 110 divided by 2 is 55 degrees. All right, I want you to take a moment. Press pause and do example 3 and 4 and then check them. Okay, so you're going to press pause, you're going to work through example 3 and 4 and check them here. Make sure you know how to do it. Check your equation, check your solution. Okay. And then you have the rest of class to study your properties. Make sure your notes are completed. Tomorrow we're going to be working on page 10 and 11 and getting ready for a quiz at the end of the week on all of our quadrilaterals so far, parallelogram, rectangle, rhombus, and square. So thank you guys for paying attention. I will see you soon, and we'll do some questions. Don't forget our help session on Wednesday if you need it. Thanks, guys.